To get x, it will be the determinant of x over the initial determinant. Determinant of x over the initial determinant, making it x equals dx is 0, 0 over 45, and I'm sure finally the answer becomes what? 0. You understand? So x is 0. So let's get y. Determinant of y, we will close y and use this one to replace problem, not the finish. You understand, sir? So now then give us this one again. This one SS1 work for further mass, SS3 work for normal mass. This question now very simple, but then say make we use determinant method, otherwise known as CRAMMERS rule. Let's go there. Mo no waste time at all. Mo touch am. Enjoy the show. Alright, then give us these two linear equations. For me, let me call this equation 1. Let me call this one equation 2. Alright. Okay, what I'm going to do, we have the variables x and y. I'll first of all use the coefficients of the unknowns. The coefficients of the unknowns to form my first matrix. That is, for me to get the first determinant. The first determinant. In other words, let me just use the letter D. Let's say the original determinant. I will form a matrix with the coefficients. That is 10, 7, 5, and 8. I will form a determinant matrix with the use of their respective coefficients. Do you get? Now, how do I get my determinant? It's simple. Main diagonal, the product of the main diagonal minus the product of the second diagonal. Do you get? Meaning 10 times 8 minus 5 times 7. Do you understand? I'll be right back. And this will give me 80 minus 35. And that would be 45. So, using the coefficients of the unknown, my initial determinant will be what? 45. Now, I want to find x. What I will do is I will close this x, everything about x, and use this constant to replace it so that I can get x. Meaning, determinant of x will give me, like I said, close this one because these two carry s. Use this one to replace it. That means 14, 7, 16, 8. Did you see it? If I'm looking for x, I will carry these constants, fix them here, and collect the remaining coefficient. That's just I close this one. I place 14 here, 7. I place 16 here and 8. That's exactly what happened. Then I will find the determinant again. Getting the determinant, I have said this is the main diagonal. which is 14 times 8 minus 16 times 7. 16 times 7. Please do not forget the order. Main diagonal minus second diagonal. And that's 14 times 8 will give you 112 minus 16 times 7 will give you 112 again. Let's verify. 14 times 8, 112. 16 times 7, 112. So 112 minus 112, you automatically give me what? 0. So to get x, it will be the determinant of x over the initial determinant. Determinant of x over the initial determinant, making it x equals dx is 0, 0 over 45, and I'm sure finally the answer becomes what? 0. Do you understand? So x is 0. So let's get y. Determinant of y, we will close y and use this one to replace it. Do you understand? Close y, so I'll be having 10. Instead of this y, I'll put 14 there. 14. Then here will be 5. Instead of this 8, I'll put 16. That will give you 16. Don't forget leading diagonal minus second diagonal. I hope it's understood. And that will give you 10 times 16 minus 5 times 14. Do you get? And of course, if you go further, this will be 160 minus 70. And that will be what? 160 minus 70 will give me 90. So to get y, it will be the y over determinant, the original determinant, which is 90 over 45. And if you go further, y will be what? 2. Therefore, x is 0, y is what? 2. Very simple. You can verify. You fix these values in the first equation. X is 0, so 10 times 0 will give me 0, plus y is 2. 7 times 2 will give me 14. So you can test it again here. X is 0, 5 times 0, 0, plus 8 times 2, 16. Absolutely, we are correct. This is another way of solving simultaneous equation. You solve simultaneous equation with the use of determinant method, also known as CRAMMERS rule, or you use matrix method. So let's save matrix method for another day, but this is just CRAMMERS rule or determinant method. Thank you very much and do have a nice day. Bye.